The next topic we'll be looking at is parametric curves. But before we begin the discussion of parametric curves, there's some basic nomenclature or terminology surrounded on just curves in general. So what do we mean by a curve, and what are some of the adjectives we can use to describe curves? So we start with just a plane. Start with a plane. Something like this. So we have the xy Euclidean plane, and a curve is just a set of points that can be drawn without lifting your pencil from the page. That is a curve. Here's another curve. Okay, so curves are things like this. A graph of a function is an example of a curve. A circle is a type of curve. A hyperbola is a curve. So there's lots of curves that we've seen before, but in general it's just a set of points that are connected as so. So what are some of this terminology? So first of all, a bounded curve. Bounded curve just means that it doesn't go out forever. So there might be a curve, like say, think of the graph of arctan, or just tangent of x. The graph of tangent of x has vertical asymptotes, so therefore it kind of escapes and becomes arbitrarily far from the origin. Or e to the minus x, right? So e to the minus x decays exponentially, but it goes out to infinity, right? So that's a curve that's unbounded because it becomes arbitrarily far from the origin. So a bounded curve is basically, or let's say a curve gamma is bounded if there exists a positive number r greater than 0 such that x squared plus y squared is less than r squared for all points x and y contained in the curve gamma. So in other words, there's some maximum radius so that the maximum distance to the origin is fixed. Right, so if we draw coordinate axes like this, let's change the color. So we have some sort of circle like this. So if you imagine a circle centered at the origin of radius r, the circle is described by the equation x squared plus y squared is equal to r squared. So x squared plus y squared less than r squared is the interior of this circle, so it's the inside portion. Now, a bounded curve just means that for some value of r, some finite positive number, your curve is never going to get beyond that radius. So your curve stays in here. So it's like that. There is the curve. It never escapes beyond r for some r. It might extend very far away, but it will always basically come back. So it won't escape to infinity. The curve does not become arbitrarily far from the origin. There's a maximum limit to how far from the origin you can get on your curve. Okay, so the next definition for curves are open and closed curves. So a closed curve is essentially a curve that comes back to its starting point. So a closed curve is one that returns to its starting point. So for example, that is a closed curve. This is another closed curve. A circle is a closed curve. An ellipse is a closed curve. Something like this is a closed curve. Something like that is a closed curve. So the curve's allowed to intersect itself, but it always makes a complete loop. So it's like a it's like a loop, right? It's a piece of string that forms like a circle. So you can always bend it into the shape of a circle. Now an open curve is one that has two endpoints. So an open curve is much more like a piece of string. So you have two endpoints like this, like that, or maybe something like this. So these are open curves, and then these ones are closed. So that's what an open and closed curve looks like. Now we saw examples where the curve just looks like a loop like this, and then examples where the curve comes back around and intersects itself. So there's another definition. A simple curve is basically a curve that never self-intersects. So basically, it never comes back and crosses its own path. So to see this, to see what this would look like, even though I have some examples right there, so a simple closed curve would look something like this, right? It can't cross itself. So then something like this that's supposed to just match up like there. This is closed, but not simple. It's not simple because it intersects itself right at that point right there. So that makes it not simple. And then there's a famous result in topology. It seems obvious, it's an obvious statement in terms of your intuition, but it's a famous result. That's the Jordan curve theorem. That basically says any simple closed curve, basically divides the plane into two separate regions. So here's our picture of a simple closed curve. In fact, let me just make another one. So our simple closed curve is one that, okay, I guess we just start with a fresh picture. So our simple closed curve is something like this, and the Jordan curve theorem says that this divides the plane into two regions. So there's an interior region, right, a region bounded by the curve, and then there's this exterior region out here. So pretty intuitive statement, right? If you have a simple closed curve, you're either inside the curve or you're outside of the curve. So that's essentially, in theoretical mathematics, it's a much more difficult result to prove, but that's essentially the statement of the theorem. So we'll be using this terminology, simple curve, simple closed curve, open curve. So we'll be using this, and basically you just need to have the simple intuitive picture, right? A simple closed curve is a curve, it's a loop that doesn't self-intersect. This is a loop, this is a closed curve that's not simple. So this is closed, simple, closed, not simple. And then we can have an open simple curve, a simple open curve like this, or an open curve not simple, something like this. Right, so the non-simple open curve intersects itself. So that's the basic terminology to use to describe curves.